Welcome back. Today we are looking at the halogenation of alkanes, specifically, the free radical chlorination of methane. This is a classic substitution reaction, where a hydrogen atom in methane gets replaced by a chlorine atom. But here's the catch: it doesn't happen automatically. It needs light or heat to get started, and it proceeds through a free radical mechanism. Let's break it down step by step. Here's the overall reaction for monochlorination. Methane reacts with chlorine gas in the presence of light or heat to give methyl chloride, also called chloromethane, and hydrogen chloride as a byproduct. But if you have excess chlorine, the reaction doesn't stop there. The product can keep reacting. Methyl chloride becomes methylene dichloride, then chloroform, and finally carbon tetrachloride. So to get just one product, you need to control the amount of chlorine. Otherwise, you get a mixture of polychlorinated products. Now let's look at the mechanism. It happens in 3 stages: initiation, propagation, and termination. Step 1. Initiation. The chlorine-chlorine bond is weak. When we apply light or heat, it breaks homolytically, meaning each chlorine atom takes 1 electron from the bond. This gives us 2 chlorine radicals, highly reactive species with an unpaired electron. Think of radicals as hungry atoms that want to steal an electron to become stable. Next is propagation. This is where the actual substitution happens. It occurs in 2 steps. Step 1. A chlorine radical collides with methane. It pulls off a hydrogen atom, forming HCl and leaving behind a methyl radical, CH, with an unpaired electron. Step 2. This methyl radical is also highly reactive. It attacks another chlorine molecule, stealing 1 chlorine atom to form methyl chloride, our desired product, and regenerates a new chlorine radical. And here's the key: this chlorine radical can go on to react with another methane molecule. This creates a chain reaction, and that's why a single radical can lead to thousands of product molecules. Finally, we have termination, the step that stops the chain reaction. This happens when 2 radicals collide and combine, forming a stable molecule. There are 3 possible combinations. A methyl radical combines with a chlorine radical to form methyl chloride. That's actually another way to make our product. 2 chlorine radicals combine to reform chlorine gas. 2 methyl radicals combine to form ethane, a byproduct. Once radicals are consumed, the reaction stops. Let's quickly recap. Halogenation of alkanes is a substitution reaction. A hydrogen is replaced by a halogen. It follows a free radical mechanism with 3 stages: initiation, propagation, and termination. You need light or heat to break the halogen-halogen bond. And if you use excess chlorine, you'll get polychlorinated products like chloroform and carbon tetrachloride. One more thing: this reaction works for fluorine, chlorine, and bromine, but fluorine is too violent, iodine is too slow. Chlorine and bromine are the most useful in practice. Thanks for watching. If you found this helpful, please like, subscribe, and hit the bell for more organic chemistry content. See you next time.